Okay, so hopefully you saw in the first video that limits, you have a basic understanding of limits. Just to recap, essentially a limit is when you plug in some number, c in this case, what that function should equal. And normally limits is like a theoretical number, it actually can't exist, but you can try and imagine what that number would be. As we've seen here, a limit basically accounts for what happens as you get closer and closer into your c value and what would equal. So now another really important concept to get is limits at infinity, where the limit as x approaches infinity. And these are really not that hard because there's a few rules that we can use, and essentially we can use horizontal asymptotes to figure out what the limits of some of these functions are. And just for me, the shorthand HA means horizontal asymptote. So there are 3 rules we can use. So rule number 1 is, let's just look at a function. Right? So you have some number on top. Let's just say in this case you have 3x squared over 2x cubed. And when I do, let's just say 3x squared like plus 1, and then this one minus 2. So when I'm saying these rules, it's all about the degree. What is the highest power in the numerator and the denominator? So in this case, the highest power is 2, right? Because it's x squared. And in the denominator, the highest power is 3, x cubed. So essentially when I'm referring to the degree, it means the highest x power in the numerator and in the denominator. So what happens when the degree in the numerator, that's just my short for numerator, is equal to degree in the denominator? And just an example of this is let's just say 3x squared over 2x squared. As you can see, you have x squared in both the top and the bottom. And what happens if this is the horizontal asymptote, which is equal to the limit, is equal to the leading coefficient on the top of the numerator over leading coefficient of the top over the leading coefficient bottom. So in this case, both the degree in the numerator, 2, is equal to the degree in the denominator, which is also 2. And in this case, the leading coefficient, which is the term before x to some power, is 3 in the numerator, and the denominator is 2. So in this case, the limit would equal 3 over 2. And that's all there is to it. It's relatively easy and straightforward. So if the degree in the numerator is equal to the highest, if the highest degree in the numerator is equal to the highest degree in the denominator, then it's simply the fraction of those coefficients. So in this case, you have 3 over 2. And that's a horizontal asymptote, and that's the limit. So relatively easy. The second rule is when the degree numerator is less than the degree denom. So an example of this would, let's just say 3x squared over 2x cubed. Now in this case, this one is relatively easy. The horizontal asymptote is equal to the limit. And in this case, it just equals 0, right? Because if you imagine this, if you were to put in infinity squared divided by infinity cubed, the infinity cubed it's arbitrary plugging in these numbers. And essentially this one is going to be larger than that, and dividing by infinity theoretically gives you just 0. So that's all there is to it. That one's relatively easy, and these are just good just to know, just to memorize. So just to recap, the first one, if the degree in the numerator is equal to the degree in the denominator, the horizontal asymptote, which equals the limit, is just the leading coefficient of the top over the leading coefficient of the bottom. And if your degree in the numerator is less than the degree in the denominator, because in this case 2, is less than free, then your limit is just equal to 0. So that's a relatively easy one. And then the third rule, as you can probably infer, is if the degree numerator is greater than degree denominator. So just a quick example of this, let's just say we have 3x cubed over 2x squared. As easily it can be told that you have 3 is greater than 2, so we should use this rule. And in this case, there is no horizontal asymptote, and thus the limit equals infinity or just does not exist. Infinity and does not exist are the same thing. Either one is appropriate to say. So these are the 3 rules, and with these you can essentially solve all types of limits at infinity problems. And so just an important thing to note, if you have some number, just using a pound sign to represent some number, over infinity, that's going to equal 0, right? Because let's just say if you have 1 divided by 10, that equals 0.1, and you have 1 divided by 100, that equals 0.01, and 1 over 1,000, that equals 1, or that equals 0.001. And as this number just keeps getting bigger and bigger, eventually at an infinite, at a number that I don't want to say equal to, because infinity is a limit, is not a number, it's just a constant. But if you have some number over infinity, it's essentially just going to equal 0. So that's just an important thing to keep in mind. So now we're going to go over some examples. In the first one, we have the limit as x approaches infinity of 2x cubed plus 5 divided by 3x squared plus 1. So in this case, our degree in the numerator is equal to 3, and our degree in the denominator is equal to 2. So the numerator degree is greater than the denominator. So in this case, we use rule number 3, when the degree numerator is greater than degree denominator. And we can say that the horizontal asymptote, there is none, and thus the limit is equal to infinity or does not exist. I would personally just say it's better to write does not exist in these cases, because infinity is not a number, it's a constant, so just simply write does not exist. But if you see infinity, it's the same thing as does not exist. So let's go over to the next one. The limit as x approaches infinity of 2x squared plus 5 over 3x squared plus 1. As you can tell, both of them have squares, so they equal each other. So num is equal to denom. And in this case, we use our rule number 1, the leading coefficient of the top divided by the leading coefficient of the bottom. So in this case, our leading coefficient of the top is 2, and the leading coefficient of the bottom is 3. So our limit is equal to 2/3. And let me just write does not exist up there. So in this case, the limit is just equal to 2/3, relatively easy. So now in this case, we have the limit as x approaches infinity of 2x plus 5 divided by 3x squared plus 1. So as you may or may not notice, in the numerator, there is no power. However, just any x, just standing alone with no power, is actually x to the 1. X to the 1 is just simply equal to x. So in this case, our degree in the numerator is just 1, and our degree in the denominator is 2. So thus, our degree in the numerator is actually less than the degree in the denominator. And thus, we use our rule number 2, and the limit, the horizontal asymptote, which equals the limit, simply equals 0. Now here's another one. This one's kind of a trick. It's a little different from what we've been doing, but it's actually not that hard. The limit as x approaches infinity of sine of x over x. So as you remember here, if we divide anything by infinity, the limit simply equals 0. And that's all to it. As you can see, limits at infinity are relatively easy. It's just important to memorize these 3 rules. Hope that helps.